In 2003, near the southwestern coast of Australia, researchers fixed a small tracking device to a healthy great white shark and then watched as she slipped away into the open sea. 4 months afterward, that same device turned up, washed onto a beach. The shark never did, and the information stored inside the tag showed something that was not supposed to be possible. A 500-pound apex predator. By every rule of the ocean, nothing should be hunting one of those. But whatever ended up on the other side of that transmitter had swallowed her whole, then carried her almost 2,000 feet straight down into the darkness. Something had eaten her, and scientists would spend most of the next decade trying to understand what had happened to the shark that disappeared. The year was 2003. A team of researchers was working off the coast of southwestern Australia, carrying out the first large-scale great white tagging project ever attempted in those waters. Filmmaker Dave Riggs was there, recording the work. They came up beside a healthy 9-foot female weighing about 500 pounds. There was something in the way she moved through the water, a sense of possession, a quiet confidence that did not feel like aggression so much as absolute certainty. Someone among the crew began calling her Alpha. The name stayed with her. Keep those figures in mind for a second. 9 feet, 500 pounds. This was not a young shark, not some animal wandering at the edge of its territory and still learning how the world worked. This was a mature apex predator, the sort of creature that had held a place at the very top of the ocean's food chain for millions of years and had never needed to glance behind it. The instrument they placed on her was a data logger, compact, tough, built to perform one specific task for months at a stretch without sending out even one signal. It measured depth. It measured the temperature of the water surrounding the shark. It recorded light levels and motion moment by moment, storing everything inside itself. It was not communicating with anyone. It simply waited. Then, on a date set in advance, it would release from the shark, rise to the surface, and send all the data it had gathered to a satellite. From that, scientists could piece together where the animal had gone and what it had gone through, as long as the animal was still carrying it. But here is what matters about that little device. It was the only witness. No camera trailed Alpha into the open ocean. Nobody was watching. Whatever happened to her out there happened in complete silence, hidden from every human eye. The only account that would ever exist was the one written inside that recorder. 4 months after she was tagged, the device returned, but not by satellite. First, it came back physically, washing onto shore about 2.5 miles from the place where it had been attached. The information was pulled from it. The numbers appeared on a screen. Riggs was in the room. Everyone expected something normal. Slow cruising routes, temperature changing gently as depth changed. The broad, easy loops of a large shark traveling through territory it knew well. That was not what the data showed, what the recorder showed. The tag revealed a descent, but not a slow dive. It was a plunge, nearly 1,900 feet, in just minutes. Then the temperature reading did something that brought the whole project to a halt. 2 numbers. That was all it took. And once Riggs realized what those 2 numbers meant when placed together, this was no longer simply a research project. It became a question that would stay with him for years. Before getting to those numbers, I want you to really feel the weight of what kind of animal we are talking about, because I think most people have a vague idea that great whites are dangerous without ever truly sitting with what that means. A great white shark is not just a big fish with very effective teeth. It is what happens when millions of years of evolutionary pressure are shaped by the ocean into something that functions near the outer limit of what biology can do. The biggest individuals grow beyond 20 feet and weigh over 5,000 pounds. Their senses can pick up a single drop of blood spread through huge amounts of water. Tiny organs gathered around the snout can detect the electrical signal of a heartbeat hidden beneath sand. In quick surges, they can move through water faster than your mind could even register the danger. Their teeth are saw-edged, constantly renewed, arranged in row after row, so when one snaps off, another just shifts into place. This is the ocean's hunting machine at its most perfected. Hold that picture in your head for a second. A creature able to scent blood from a wound across a huge stretch of open sea, able to sense a heartbeat through solid ocean floor, and close the gap before instinct has time to react. But this is the part most people rush right past, and it matters even more than the teeth, Being an apex predator is not only about being big or fast, it is about where you sit in the order of things. An apex predator means an animal that nothing else hunts. Every creature beneath it builds its life around staying out of its way, and above it there is nothing. That is what apex means. The top. For all the years marine science had spent studying great whites, that was the accepted picture. Orcas had been seen bothering, and in a few recorded places, sometimes killing great whites. Big sharks occasionally fought over carcasses, but a creature that intentionally hunted a full-grown great white, killed it cleanly, and ate it as food. That did not fit the model. It was not meant to be possible, and that is exactly why no one in that room wanted to speak aloud what Alpha's tag was showing them. The two numbers, the first number was depth. The tag fell to almost 1,900 feet. Even before anyone looked at anything else, that reading by itself was already wrong. Great whites are not animals of the deep ocean. This species is made for the bright, productive water near the surface, the coastal shallows. The upper layer where sunlight still reaches and prey is plentiful. The vast majority of their lives takes place within the first 1,000 feet. That is their domain. A sudden straight drop to 1,900 feet is not a feeding dive. It is not exploration. When a tag records that kind of fast, extreme descent over only minutes, the possible explanations narrow down almost immediately. Alpha was almost certainly not diving under her own power. Something was pulling her down. Something capable of reaching 1,900 feet quickly, forcefully, and apparently with little difficulty. And think about what that depth means. At 1,900 feet down, sunlight has vanished completely. The pressure is immense, dozens of times stronger than what you feel at the surface. It is freezing. It is pitch black. It is silent. This is not a place where a coastal hunter simply drifts by. Something hauled Alpha into a world that had never belonged to her. It did it in minutes. It left no noise, no trail, no witness. Let that settle. Because then the second number appeared. Temperature. At 1,900 feet off the coast of Australia, the sea is cold. Not just chilly water cold. Deep, crushing, truly icy cold. Water at that depth is around 46 degrees Fahrenheit. If the tag had merely detached and sunk that far, or if Alpha had died and descended with it still fastened, 46 degrees is exactly the reading you would expect, cold and growing colder as the depth increased. But that is not what it recorded. The temperature rose. It went from about 46 degrees to a steady 78 degrees Fahrenheit, an increase of more than 30 degrees, and it did not flash upward for a moment like a failing sensor might. It stayed fixed at 78 degrees, 1,900 feet down, in water that should have been near freezing. There is basically only one explanation for that. A tag does not record a warm, steady 78 degrees at extreme depth in an icy ocean unless it is no longer in the ocean. It was inside something with a warm internal body, something living that had swallowed Alpha, tag, and all, and then carried her down with the meal still inside it. Imagine it the way Riggs had to imagine it. Something out there swallowed a 500-pound great white shark whole, dove almost 1,900 feet, and then just continued on. And not a single person on the surface saw anything. No fin, no disruption in the water, no photo, no eyewitness. The only reason any of us know it happened is because a piece of plastic washed up on a beach 4 months later carrying the proof. Riggs has said he read the data again and again. Unable to believe the figures were genuine, he still could not force them to mean anything except exactly what they showed. The shark had been consumed. That was where the question began. The suspects. After the team accepted what the data was saying, they started moving through every possible candidate the ocean could provide, and one by one, each explanation fell apart. First on the list was the orca. We already know orcas are capable of killing great whites. Around South Africa in particular, orcas have refined a method that feels almost surgical. They turn a shark upside down, sending it into a paralyzed trance, then slice into the body cavity and remove the rich, nutrient-packed liver. Efficient, ruthless, impressive, no matter how you look at it. At first, the orca looked like a solid match. An orca's stomach filled with warm prey, mixed with a mouthful of cold seawater, could reasonably create something close to that 78-degree reading. The temperature did not rule it out, but the depth did. Orcas are not animals of the deep. They hunt close to the surface. Even the deepest dives ever recorded for them do not come near 1,900 feet. An orca does not simply haul prey down to that depth and remain there. The behavior does not fit the animal. The orca remained a possibility, but it dropped much lower on the list. Second suspect, the sperm whale. This is a creature that truly belongs in deep water. Sperm whales pursue squid down to depths of several thousand feet, much deeper than alpha ever traveled. The biggest males can exceed 60 feet and weigh more than 100,000 pounds. A sperm whale's throat could take in a 9-foot shark without much trouble. In terms of depth, there was no issue, but the temperature worked against it from the other side. Sperm whales are warm-blooded mammals with internal temperatures around 97 to 99 degrees. 78 degrees is much too cool for the inside of one. And their whole feeding strategy is based on hunting soft-bodied animals in the deep, not big surface predators. Wrong temperature, wrong food source. Eliminated. Pay attention to the pattern here, because it is basically the entire mystery in miniature. Every suspect big enough to reach that depth was too warm inside. Every suspect with the right temperature range could not get down that far. The data had silently built a box around the predator, and almost nothing in the whole ocean could fit inside it. The team next considered other large sharks, maybe a huge tiger shark or an oceanic white tip. Both are aggressive, and both will take advantage of almost any feeding chance. A tiger shark especially will try to swallow nearly anything its jaws can handle, but neither species becomes large enough to eat a 9-foot great white whole. The largest tiger sharks ever recorded reach only about 14 feet, and if you are going to swallow a 9-foot shark completely, being just a little bigger than your prey is not enough. You have to be massively larger. The numbers would not work. There was even a short period when someone suggested a colossal squid, an animal theoretically big enough to wrap around a shark and drag it down into the darkness. That idea did not last. A cold-blooded invertebrate does not have a warm interior. Its body temperature is only the temperature of the water around it. There was no warm chamber to detect. One after another, every normal answer disappeared. Orca, wrong depth. Sperm whale, wrong temperature. Wrong prey. Large sharks, not large enough. Squid, cold-blooded. And once that list had run out, the team found themselves facing a possibility that was somehow completely obvious and almost too bizarre to say out loud. The predator revealed, what if the animal that ate the great white was another great white? Not a slightly bigger opponent that won a fight, not a territorial clash that ended in death. A great white so enormous that most marine biologists had never seriously considered it. A shark so large that a 9-foot, 500-pound great white was simply food to it. And they did not arrive there by guessing. They reasoned their way there. The temperature was the crucial clue. Most sharks are cold-blooded. Their internal temperature is the same as the water surrounding them. That is the end of it. But great whites are not like most sharks. They are members of the mackerel shark family, and they have an unusual adaptation known as regional endothermia. Through a highly specialized web of blood vessels, they capture and reuse the warmth created by their own muscles, allowing their core, eyes, brain, and digestive tract to stay noticeably hotter than the surrounding sea. That is what lets them remain quick and deadly even when the water is cold. So take that idea to its next step. The stomach of an average great white may sit somewhere near 65 to 70 degrees, and down in icy deep water, even that estimate may be on the high side. 78 degrees is warmer than what a normal mid-sized great white would usually generate. But when the great white is much larger, the whole calculation shifts. A bigger body means more muscle tissue. More muscle tissue produces more heat. Greater mass also holds on to that heat much better while the cold pushes in from the outside. In the gut of a truly gigantic great white, a steady 78 degrees is not impossible at all. It is precisely the kind of reading you would expect. What first seemed like a faulty signal suddenly indicated one specific type of creature. The depth also made sense. Once scientists stopped assuming that great whites only remain near the surface, the image became clearer. These sharks have been recorded diving beyond 3,000 feet in the open ocean. 1,900 feet is an extreme depth, but for a very large individual, it is absolutely attainable. That left only one problem. How big would a great white have to be to swallow a 9-foot shark whole? Researchers who study this type of predation put the estimate at about twice the prey's length. Apply that to what the tag showed, and the predator comes out somewhere around 16 feet long, with a weight of more than 2 tons. That would place the shark right at the upper limit of what the species is thought capable of reaching, and maybe even a little beyond it. If you allow yourself to imagine the moment, it is short and brutal, a larger shadow lifting out of the darkness below. Great whites attack with speed and full commitment, striking from beneath in one decisive blow, and then came the long drop into black water with the meal still inside. The tag did not capture the attack itself. It captured what happened after, the descent, the heat, the plunge, and that aftermath gives more than enough evidence to understand how it started. What else have we misunderstood? This is the point where it stops feeling like arithmetic music and starts to become truly disturbing. For decades, there have been credible reports from fishermen, naval crews, and researchers throughout the last century, describing great whites measuring 20 feet or more. Science, for a long time, set those stories aside as overstatements, distorted memories, and the natural exaggeration that comes when a frightening encounter is repeated over many years. But what if those accounts were not inflated at all? What if the ocean contains great whites of a size we have simply never succeeded in tagging, measuring, or photographing? Animals that spend their lives far offshore in deep open water, away from coastlines, boats, and the shallow bays where nearly all our observations take place. The more you think about it, the more reasonable it becomes that we would have missed them. The biggest and oldest females would be the rarest members of an already uncommon species, traveling thousands of miles through open ocean and never surfacing for us. A shark like that could live a 50-year life without ever passing within view of a research vessel. We did not fail to locate her because she was deliberately hidden. We failed because we were searching in the wrong part of the sea. The team's conclusion pointed toward an extraordinarily large female great white. In this species, females grow far bigger than males. The largest confirmed sharks have come close to 20 feet and weighed more than 4,000 pounds. And when the researchers compared Alpha's recorder with tracking data from other large white sharks moving through those same waters, the pieces matched. Temperatures recorded from larger animals lined up with the warmth measured inside the tag. The depths, the distances, the movement patterns, all of it fit with the presence of a huge female great white that had never been officially documented. She had been out there all along, passing through that water, doing exactly music, what top predators are built to do. Then, on one morning in 2003, she encountered a 9-foot great white and handled it as if it were breakfast. After that, she sank almost 1,900 feet down into the darkness to finish eating somewhere no human would ever witness it. I have no idea how to make that sound less disturbing, so I will not pretend I can. But here is the part almost no one brings up, because the headline by itself is already too powerful. A huge great white shark ate another great white whole. Just that one sentence is enough to make somebody quietly cancel their beach trip and reconsider every choice that ever brought them close to open water. Honestly, that is completely reasonable. I am not judging anybody, but the headline is actually the least unsettling piece of it. Once the researchers verified what had happened to Alpha, they did what careful scientists always do when something that seems impossible drops right in front of them. They returned to the data, searching for patterns they had once written off or overlooked, and what they uncovered reaches much farther than a single morning off the coast of Australia. Great whites preying on other great whites is not some bizarre fluke. It is not a one-in-a-million meeting between two animals that happen to be in the wrong place at the wrong moment. It is behavior that has been recorded, and the proof has been sitting in open view for years. Marine biologists have understood for a long time that great whites can be cannibals. Bigger animals push smaller ones around at feeding grounds. Young sharks are truly in danger from the adults moving through the same water. That behavior even begins before they are born. Growing pups eat their unhatched brothers and sisters inside the womb. It is such a recognized survival strategy that it already has a name in scientific writing. Dead great whites have been found with enormous bite marks on them. The curve, the spacing, the serrated edges, music, could only match the jaws of another great white. And this is not limited to sharks that were found dead. Divers and scientists have photographed living great whites with old, healed scars, showing that same impossible-to-mistake pattern. Those were sharks bitten by their own kind that somehow lived through it. Each scar is the trace of an event nobody saw happen, a brutal clash preserved only in tissue that survived. More recently, scientists following a pregnant porbeagle, a smaller cousin of the great white, recovered tracking data indicating the animal had been attacked and most likely eaten by a larger predator, with a great white listed among the main suspects. Described as the first confirmed predation of a porbeagle anywhere on Earth, it repeats the same lesson across different studies and different oceans. Being a big, dangerous shark does not mean you are safely sitting at the very top. It only means that whatever is capable of eating, you must be even bigger and more dangerous. If you look at each case separately, you can always explain it away. Maybe it was a fight over territory, a struggle around a carcass, or two large animals having one very bad encounter in close quarters. Scientists are taught not to build dramatic claims from a few isolated pieces of evidence, and they are right to be cautious, but place the entire record side by side. Stretch it out over decades. Put Alpha's tag data on top of all of it, and it becomes impossible to dismiss everything as simple aggression. The image that forms is different. The biggest great whites are not merely competing with the smaller ones. At times, they are eating them. Apex predation is taking place within a single apex species. The food chain people assumed stopped at the great white does not actually stop there. It rises higher into a size range that ocean science has only barely started to understand. That means the mental diagram most of us carry around, with the great white on top and every other creature neatly placed underneath, is not correct. And if we were wrong about that when it comes to the most studied, most filmed, and most famous predator in the whole ocean, then the next question is the one that should keep marine biologists up at night. What else have we misunderstood? There is a reason this remained hidden for so long. It comes down to one simple fact. We have hardly looked at all. The open ocean is so enormous, it is almost impossible to comprehend. The Pacific by itself spans about 60 million square miles. Put every ocean on Earth together, and you are looking at more than 100 million square miles of water, and we have only truly investigated a tiny part of it. The deep open sea, basically everything beneath about 1,000 feet, is, in any practical sense, hidden from us. Whatever takes place down there, we are not present to see it happen. And the problem goes further. Even when great whites are the subject of research, the sample sizes are limited. Worldwide, their population is only in the low thousands. The number of individual sharks that have ever carried a functioning tag is just a small portion of that. We are making firm statements about a whole species by looking at only a few dozen animals. And even that has another problem, because the sharks that get tagged are not random. Scientists operate in places where sharks approach the coast. Those animals are usually the smaller, younger ones. The 20-foot females, the kind large enough to do what was done to Alpha, stay far offshore in deep water, away from the boats. It is like attempting to understand wild elephants while only studying the calves that wander near the fence. Put all of that together, and the effects are not theoretical anymore. Great whites are protected in many parts of the world, and the plans designed to protect them depend on population models. Those models include human dangers, fishing pressure, the fin trade, and the destruction of habitat. What they do not seriously include is great whites being eaten by other great whites. If the biggest sharks are quietly taking smaller ones out of the population, then the real picture is messier than the models suggest. The survival rates and recovery forecasts based on those models might simply be wrong. And this is about more than just counting sharks. We already understand that when great whites are present, they change how everything below them behaves. Seals, sea lions, smaller fish, and whole communities arrange their lives around that danger. If enormous great whites are changing their own population from within, then the consequences move down the entire chain without being counted. Then there is the piece I keep coming back to. We have always treated the great white as the marker for the very top of the ocean, the standard, the limit. But if a great white can sometimes become prey for a larger member of its own species, then that limit is not where we thought it was. The apex is not some permanent point. It shifts. It depends on size. And that quietly opens the door to a much bigger question. How many other animals that we confidently label apex predators are, in reality, prey for bigger, deeper, rarer members of their own species, creatures we have never tagged, never recorded on film, and never documented? Judging by everything Alpha's tag showed us, the truthful answer is that we do not know. And ignorance is a scary position to be in when the choices you make affect entire ecosystems. We never gave her a name. Not Alpha. The shark that was eaten. I mean the other one, the hunter. She has no label, no file, no photograph connected to her. She passed through the waters off southwestern Australia, carried out the single most extraordinary act science has ever inferred about her species, and then disappeared again without ever being seen. If you want to picture what an animal like that could look like, think about deep blue. Deep blue is real. She is the biggest great white ever reliably captured on film. A female believed to be about 20 feet long and around 4,500 pounds. She was filmed in 2013 near Guadalupe Island, Mexico, and is thought to be close to 50 years old. She is astonishing. Beside her, a research cage looks almost like a toy. And I want to be very clear here, because this part matters. There is no proof tying Deep Blue to what happened to Alpha. They are different animals in different oceans. Nobody has ever connected them. I mention her for one reason only, to show that great whites really can grow that large. The animal that ate Alpha was not some monster from a legend. It was a shark. A normal shark of an exceptional size, doing something sharks normally do. In a way, that feels more unsettling than any old myth, because we prefer to believe we have basically figured the ocean out. We charted it, labeled it, divided it into zones, biomes, and neat little classifications, gave every creature a Latin name and a place on a diagram, then stared at that diagram and convinced ourselves we knew what lived beneath the surface. But we do not. Even in the era of satellites, we are still coming across brand new species of large sea animals, beings bigger than human beings, somehow missed for entire generations. And if animals of that size are still being discovered for the very first time, then the certainty that we have already found the biggest great white in the ocean begins to sound less like science and more like hope. The sea contains creatures we have not yet laid eyes on, habits we have never witnessed, and connections between species and inside the same species that no one has ever documented. When Alpha's tag washed onto shore 4 months after she vanished, it felt like a message sent up from the depths. In other words, it was saying, there is something down here you failed to include in your calculations, something bigger than you thought could exist, something that sees your apex predators as food and sinks almost 2,000 feet down to digest its meal alone. The great white took millions of years to become the most terrifying hunter the ocean has ever made. And then something saw one of those hunters and decided it was lunch. Somewhere in that vast water, another tracker is probably already fastened to another animal, silently recording the next truth we were never meant to learn. When that device finally drifts back to land, I will be here to tell you exactly what it discovered. Subscribe to Reef Discovery now so you are here when that happens, because the ocean has not run out of ways to shock us, and honestly, of music. I believe we are only starting to grasp what is really waiting in the dark.